Right, thank you. Now let's continue. Now, remember, this is our target molecule. This is our target molecule. This is our target molecule. So in terms of synthesis, it means that you started off with this, what we call like static material. Then you treated this like with an acyl group, right? Treating this with a, what we call like acyl group, right? In the presence of a Lewis acid. In the presence of a what? Of a Lewis acid, right? In this case, which is AlCl3. Then we will generate, right? This, what we call like target molecule that we want there, of course, plus your, what we call like, plus your byproduct there, right? Now, this now like it's going to take us to the chemistry of benzene. With benzene, like aromatic compounds, generally speaking, like they tend to be not reactive. So in a way, you must force them to react. Are you with me? How do you force them to react? Right? It means that now, like, for them to react, they need to react with very strong electrophiles. Not just electrophiles, but very strong what? Electrophiles. So once you've generated a very strong electrophile, it's then that now like a benzene will go and attack that strong electrophile. Remember, benzene does not want to lose its character, right? Of having those 6 pi electrons. It doesn't want that, right? So unless your electrophile is extremely very strong, when the electrophile is very strong, it's then that now like your benzene will begin to what? To react, right? Now, so this is our synthesis. Now let's go and see now like the mechanism, right? If I have this here, right? If I have this now like here, this is just a, what called like an electrophile, yes? But the question now like, in this nature, is it strong? Not yet. Let's see. How will it be made strong? This is what is going to happen in that action. Now, in terms of the mechanism, there's the mechanism, right? We must first generate a very strong complex. This is what we do. This here, double bond O, 1, 2, 1, 2. This here, we've got a chlorine here, 1, 2, 3, 4, 5, 6, right? It reacts with what? It reacts with AlCl3. Al bonded to Cl, bonded to Cl, bonded to Cl. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Now, remember now, like I said, this is our Lewis acid. This is our Lewis acid. Our acyl group here is therefore our Lewis base. This is therefore our Lewis what? This is therefore our Lewis base. So we've got a Lewis acid reacting with what? With a Lewis base. How does that take place? If this one now like it's going to be a Lewis what called like base, and this one is a Lewis acid, right? It means that now like remember like the definition of a Lewis acid, if you go back to what called like first year chemistry or high school chemistry, right? It's an acid that can accept, right, a pair of electrons that have been donated to it by what? By a Lewis base. So remember, we've got a p orbital here, right? That is empty, right? That can take electrons. Therefore, these electrons from your chlorine will go to that p orbital, right? If you go and look at the electron configuration of your aluminium there. Now, these electrons, there is your pair of electrons that is donated to a Lewis acid. Therefore, this now becomes your what? Your Lewis, what call it base. Then you generate a complex here. This is the complex that you generate in this case, right? You generate a Cl 1, 2, 1, 2, that is bonded to C double bond O, this here, 1, 2, 1, 2 in that case, ne? And a new bond now to what? To Al, bonded to Cl. That is the 3 Cls that were in there. The 3 Cls that were in there. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Now, your Al now like has accepted a pair of electrons, and therefore it becomes what in charge? Negative, right? So you generate here a coordinate covalent bond. So this coordinate covalent bond, it's not the same as this bond that we have here, the same method. Yes, they are all covalent bonds, but this one is coordinate. Then the chlorine here has lost that pair of electrons, and therefore it becomes what in charge? Positive. So this here is what is referred to as an activated complex. This is referred to as a what? As an activated complex. Right? Now, it is this activated complex, right, that will now yield your what? Your very strong electrophile. How will it do that? It's easy. Now, the carbon bonded to what? To chlorine, right? This bond now is going to be broken here. Because chlorine is positive and it is more electronegative than carbon, then it takes away the bond pair of electrons that it shared with carbon to generate a what? An acylium ion. There's your acylium ion. This here, double bond O, 1, 2, 1, 2, and then now, look at this now, look at this now, look at this now, right? This carbon atom, it is what in charge here? Positive. It is positive, right? That's what we have formed here. Then that side, what is that? What is it that is remaining that we have formed there? It's going to be AlCl4. I'll just write it here. AlCl4. Then we normally write this as AlCl4 minus. But remember, the minus it's here with the Al atom. But I'll just write it the usual way. Right? AlCl4 minus, that's what we've generated there. Now, what about this here now? Here you've got your carbon atom that is bearing a positive charge. You've got a double bond here. You've got a source of electrons here. Then it means that now like this here could come in here. Here to generate what we refer to as a what? A resonance. What could I hybridize what? Structure. So whereby now you end up with your oxygen that is triply bonded to what? To your carbon atom, right? 1, 2, and then like, you know, and then like where the oxygen in this case becomes what? Positive in charge. So you generate a structure like that, right? So this is your resonance structure for your what? For your acylium ion. So your acylium ion is now your what? Your electrophile. Your electrophile. Your electrophile. Your electrophile. Not just your electrophile, but a very strong electrophile that you have generated here. Right? Right? So like now, like you have now like generated a strong electrophile. So it is this electrophile now like that's going to react with what? That's going to be picked up by what? By your benzene ring. Then I will show you that like in the next what called like class. Right? Thank you for now.